Okay, so in lab today we're going to illustrate how a magnetic field torques a dipole, torques a magnetic dipole, and our magnetic dipole is just this compass needle. It's on a bearing, can turn reasonably freely. It is not strongly magnetized enough to feel the magnetic field of the Earth, but I happen to have a bar magnet here. And let's see what happens when I bring the north pole of the bar magnet near the compass needle. And you see that the south pole of the compass needle is pointing at the north pole of the bar magnet. And if I misalign it, you see how the compass needle feels a torque, which tries to line it up with the magnetic field. And because there is some friction in the bearing, it's, the oscillations are damping out, and there it is pointing at the North Pole. Now if I flip this around, I've got the south pole of the magnet here, and it is now attracting the north pole of the compass needle. So now the magnetic field from this magnet is going into the south pole, and so the north pole of the compass needle should be pointing this way after it settles down, and indeed it is. And I can chase it around like this. Now the magnetic field, say if I stop there, the magnetic field from the bar magnet is going into the south pole, and the compass needle is indeed lined up. If I want to exert a torque, I'll just flip this around, and now you see that the compass needle, the magnetic dipole, felt a torque, which is trying to line it up with the magnetic field, which is now coming out of the north pole of the bar magnet, going this way, and indeed you see that that's the direction in which the compass needle is lining itself up. So very simple demonstration showing you, first of all, that north attracts south and south attracts north, and north repels north and south repels south, and also that a dipole likes to line itself up with a magnetic field, as we've seen with equations already.